Our state irrigation engineer, and he is going to talk about irrigation water management. If you're wanting to irrigate any of your fields or your pastures, it's really important to be able to manage that irrigation water so that you can use your irrigation water as efficiently as possible. Try to maximize the production that you can get. So Randy's going to go through basics of irrigation water management and some different ways that you can practice your...
I think you just covered all of it, so I can go. Well, I thank you for inviting me out to this topic, because irrigation is what I do, and I practice irrigation, so it's really good to talk about it. So irrigation water management covers all these things I just put on the table. You saw pictures of the flow meter. And here's one in this thing. This is Hall Brown probe that they talk about. And this is really helpful to find hard pan or anything else into your field that you don't know about, because you can't see into the soil. But if you have hard pan, you will find out how deep it is. And that's what this tool, and I don't know, when I bought this one it was 25 bucks. But now they're probably...
I think it's maybe 45
Yeah, they don't go down in price. They go up like everything else. It's got a little corkscrew at the very end, and that's to take a soil sample so you can monitor the texture of the soil. And that, Ian is going to talk about soil. Soil is the background of the irrigation, believe it or not. Irrigation is water, but it goes on the soil. So you got to know the soil that you have. It's got a little ball on this, and that prevents you from pushing it in if there's no moisture in the ground for the plant to use. And it doesn't matter how big of a person you are, you will not be able to push that in if you don't have the moisture in the soil. These other items here are called tensiometers. And these things you can use in your garden, you can use out in the field. It's a hollow tube that you fill with distilled water.
Can I pass this one around?
I brought two different types so you can see their different sizes. And I got one 6 foot long at the office. I mean, these come in all kinds of lengths. But you fill them with distilled water. It's got a ceramic tip down here that if this was filled with water, you touch that tip, you can feel the moisture. It easily goes through that ceramic tip. When a plant, and this is put down by the root ball of the plant, when a plant uses water and it's pulling moisture from the soil, it's pulling it under stress. It's causing stress to get that water into the root. That will take water from this hollow tube out into the soil and into the root. That will cause this gauge to start to go up. This gauge going up then indicates the tension that root has to pull from the soil. So when you see that up in anything, you get a feel for what you want to irrigate your ground at. And in clay soils, that will go up to about 70. In sand soils, and we don't see sand too much, and I don't believe you got sand out here too much, but in sand, 30 would be a top number. And that's when you want to irrigate that stuff. So I'm like Evan, I have a high tunnel. I got 2 of these in my high tunnel. I set my irrigation system to kick on when that thing says 30. And that's a sweet spot for irrigation and using tensiometers. The other thing I got here is called soil moisture sensors. This is what they look like when you buy them. This is what you look like if I'm involved and I put a pipe to them. And I marked this because I used it for demonstration, 12 inches, 18 inches, 24 inches. And that's to be embedded in the ground. I can leave this in the ground over winter. Frost does not cause any problem with these things. Freezing doesn't do anything to them. It just stops them from reporting. And you get information off of these things with a meter, which We all forgot to bring the meter, so I can't show you a meter. But that's how you record, and you see the same number that these tensiometers would record. 70 would be the time to irrigate. 30 is a sweet spot. And these things, you can just bed them in the ground, leave them alone, find the cables, you hook up the meter to the cables, and you hit a button and you get a reading.
Sometimes the hardest part is getting back to them. Like if you lose a flag or something.
Yeah, find the green wire in a green field. That's the problem. So these are tools for irrigation water management. Irrigation water management is because you have your system installed. You got the pump going, you got the sprinkler or the flood system going, and now you're managing the water. What's it take to manage the water? So irrigation water management is the act of timing. You got the water running so long. You're regulating irrigation water application in a way that will satisfy the requirements of the crop, so you're not over applying water or under applying. You're satisfying a crop without wasting the water, soil, or the plant nutrients. We heard today that in Joliet, pivots are doing something to the groundwater, or we found out more is the canal, okay? Well, that's plant nutrients. That's the nutrients getting into the groundwater. It gets in the groundwater. Do you really want that to drink? You fertilize your fields, those nutrients are going beyond because too much water is applied. You don't want to be drinking that water. But that's what management is. You match up what the crop needs so you don't have those problems. So what involves in applying water? Well, you apply water to a crop need. A crop need is like the kids we raise. When they're little plants, they want a little bit of water. When they're teenagers and they eat your refrigerator clean, they need a lot of water, and we call that peak consumptive use for crops. So you match the water application to the crop need. But we also look at what the soil can hold, or what's available to the crop. A soil can hold like your bank account. Your bank account can hold your money. The bank doesn't let you take all the money out and close the account, and neither does the soil. The soil can hold the water, but there is a certain amount of that water that the plant can't take. So anyway, we look at also erosion hazards, and we covered that. We talked about runoff conditions. So what does water quality is maintained or improved? So if you would like to prevent the erosion, the reduced labor, to minimize the pumping costs, or increase your crop biomass yield and production quality, that is the objective of irrigation water management. That is why you do irrigation water management. But you are the decision maker. You're the one turning the pump on and off. So you are the decision maker. You need to use this stuff, understand the irrigation principles, and that way you become the judge and the jury of your irrigation system, and you be able to manage it better. So the tools that you use to manage water, I just showed these tools. Well, they include the water budgets if you have a water short application. Applying the knowledge of the soil, and we talked about soil being the main character of the cropping and the water. So we allow the irrigation application rate. Every system that Tyler talked about puts water to an application rate. Soil has what we call an infiltration rate. We need, and we design, if we're irrigation specialists, and we design systems so that the application rate is not more than the intake rate. And that's what all this is talking about here. That's to prevent the runoff. That's to prevent the depercolation then. So when we look at crops, we got to have that knowledge of the crop. And again, I talked about the teenage kid in the crop water use and all that. But what happens when you put your alfalfa plant in stress and you don't know it's in stress? What happens to the color of the crop? You can tell the color of the crop. That in turn will affect the yield and the quality of your crop if you put stress. So stress in alfalfa happens right after it's cut. That's when alfalfa wants water, right after it's cut. But guess what we're doing if we're using hay? We're letting the hay cure. We're not applying water, but the crop wants water. So the idea in hay production to fit this is you get that hay off as fast as you can, then apply the water again. I actually witnessed a neighbor of mine who flood irrigated this field, then he put a pivot on it, and he waited as long with the pivot as the flood irrigation system he had. Well, then he didn't get a good second cutting, because if you don't give that water to that crop right after you get that hay off, it is stressed. Its quality is down, and you're not going to get what Tyler said was 4 or 6 tons in this. You're going to get somewhere, well, your second cutting is going to suffer, and I can't tell you what it's going to be. It's not going to be what it can be. So when you do apply water, you want to go to the rooting depths if you can do it. Not the whole depth of the soil, but the crop rooting depth. So if you're growing beans in your crop, that's different than alfalfa. If you're growing grain, that's different than beans. If you're growing corn, that's going to be, all of them are different rooting depths, so they all have a different moisture rate, and they have a different stress level that they can take. So water delivery schedule effects. Well, the flow meter is how you get to understand the delivery of the water. When you claim a water right on your field, the water right is going to be given to you in acre feet or CFS or GPM. And these meters can read any one of those issues if that's how you want it reported. But a water measurement device, we require them in NRCS. If you're doing an NRCS practice on a pivot or gated pipe, we want to see one of these in the system. Because you can't tell me what an open ditch looks like at 2 CFS. You know, I mean, I can't tell you how much water that is if I don't know the grade of the ditch or the roughness of the ditch. You put in a flow meter, these are 2% accurate. Ditch companies don't question them after that. When I was on a ditch canal in Miles City, and I had a little place, I had a flow meter like this, and every time they told the producers to turn the water off or irrigate every other day, they never stopped by me because I had a flow meter. They didn't question the flow meter. They would tell me stuff like, you can get as many amount of water as you can get in 2 fingers opening a gate. Well, that didn't tell. When I computed what 2 fingers opening a gate was, it was 19 gallons a minute for 24 hours for, I don't know, May to October, and that was 19 acre feet of water per acre. And I said, I'll put a flow meter in and I won't take nearly that much. So a flow meter, well, 2 things I think that a flow meter can do for you. One, if your design calls for 600 gallons a minute, you know that this flow meter is working based on your design because it's saying 600 gallons a minute. You got a pivot out there, and next few years and you're reading 600, what happens when this thing says 700? What would you think your pivot just did? Your pivot, the pressure regulators are not functioning correctly and more water is going out the pivot. On the sprinklers, that's a bigger application now going onto a soil that couldn't take it, and that's going to cause ponding and maybe some deep percolation if the soil can take the water in. So that's what a flow meter can do. When you see a higher flow rate than what you designed, something went wrong, and that's a mechanical fix. Something went wrong. If it's a drip system, you've got a break in the line somewhere. You got a rodent that just ate something out. You got water gushing through a drip system. You got more water than what's designed, that means something needs replacing. A wheel line, if it's used more, it's replace those little brass nozzles. And that's an indicator right there. So flow measurement is a good tool to have. So here's what I'm talking about here is make sure you count for delivery time when you schedule water. Why I put this in is because when you have water, when you want water, does the canal company give it to you the day you request it? Okay, if you see crop stress in your fields, in your crops, that's not the right time to say, I need water, because there was a guy in, I'll say he was east of Billings. It took him a week after ordering water to get water to his field. That week, at a crop using, say, a quarter of an inch a day, was using almost 2 inches of water that he didn't have in the soil. So if your crop wants it and you don't have it, that's stress. That stress is lower production. So the whole idea is kind of plan out, schedule out when the delivery time of your water comes to you so you can get it in an application. And delays will cause crop stress. So, any questions on that topic? Okay, IWM methods, I guess I'll be talking about. So irrigation can be scheduled using methods from a simple soil probe, feel, your sampling, the water using the feel and appearance, we call it. And that's this tool right here to do that. Or you can get into more sophisticated, whoop, that was bad.
And one thing too that we have in your folder is, I believe in like the middle, or I think in the...
Behind the agenda?
Yes, behind the agenda. There's the spec for irrigation water management, and it goes through the different types, and it explains soil moisture monitoring through feel and appearance, how you do that, and then it goes through these different levels. So if you wanted to, go and look back through that, it also.
And that's good to point out, because everybody that's talking today is with the NRCS. NRCS is a technical agency. If you need any help on anything you've heard today, we are the agency, non-biased. We don't represent a company. We don't represent, Netafim or Valley Irrigation, but we are a technical agency. We can explain these things in a technical way. What I was getting at is there's more sophisticated methods. This is basic, I'll say. This is what the feel and appearance can do. This gets to be the next level of sophistication. And then, like Evan with his smartphone, tomatoes saying I want water app, I guess, you can get really technical and get tools to be smartphone related. And you can turn a pivot on with your smartphone, turn it off. You got moisture sensors tapped into the panel of the pivot that will not let the pivot row come over the sensor if the sensor says it's too wet. So they automatically control. A lot of companies are going away from that kind of technology because there's a limit of liability in that. So they don't like to get into that. Basically, we call it scheduling. Scheduling when to turn water on, scheduling how far to have the water or how long, based on the water content and water use. So this will measure water content. Water use will be by the crop you're trying to grow, the crop that gives you the 6 tons or the 2 tons. So crop water use monitoring, you estimate, you use it when to estimate irrigation. Now, one thing we do in Montana is we run a checkbook program, like your bank accounts, when we all had checks and you wrote down your pluses and minuses when you wrote a check. That's the same way we do it, the water balance in the soil. These things are how we adjust the checkbook program if we read a different number. But it's all comes to do with scheduling the water based on crop conditions. And that gives you an estimate of when to apply water. So soil moisture monitoring, perhaps the most accurate irrigation scheduling tool is monitoring soil moisture, basically what I'm saying. If you can see your soil looks dark when it's wet. What's it 6 inches below that, or a foot below that, or 2 feet below that? You can't see that. So you can't judge based on the vision of the soil. These tools help us measure soil moisture, and that is the most accurate way of scheduling irrigation. So the checkbook method, and with that blue thing, that means I linked it to my computer, but I doubt if I can hit that blue and link it to your computer. So.
Yeah, I don't think so, because I don't have internet right now.
Yeah, so I won't try that, but Sienna can pull the checkbook program up if you guys are interested in seeing what it is. It's an Excel program that when you put in your crop, your soil characteristics, the water that your system is designed to, your acres of your system, and then the temperature that you see a day, precipitation events that you record in a rain gauge, it will keep a balance of your available crop moisture. When you get below what we call the MAD level, that's management allowed deficiency level, that's when crop stress happens. Crop stress means you're going to get less production. You want to stay above that. And that's where a crop, this is what's different than actual research that universities tell us. When they say, they use words like wilting point. That's when a crop dies. That's if you allow your husband to sit and water your plants when you're on vacation and you come back and they're dried and crumbly, that's the wilting point. They're dead. And they don't come back from being dead. But we don't see dead field crops, right? We see almost dry land condition crops. They go into a dormant stage. Alfalfa doesn't die. It goes dormant when we don't give it the water. So every checkbook method that I've seen from North Dakota, Nebraska, Kansas, California, and Idaho always showed a complete running balance. So if your crop wanted 0.25 inches and you couldn't give it 0.25 inches, it would go negative. Now, you know what your bank account would do if your bank went negative. They would stop they'd make you cut up your debit card and put a fee onto it. But that's not an accurate way. We don't get negative. We go into dry land conditions. Dry land conditions mean even the driest soil has some moisture to it that's giving that plant some kind of life when it builds up. But scheduling with the checkbook program, I already talked about that. We add deposits. That's irrigations, that's rainfall. Withdrawals are crop evapotranspiration. And any evaporation from the soil. Those are all losses to the checkbook program. So these tools in the checkbook program is what the methods of irrigation are. Yeah.
When you talk about your ways that you add to your program and the parameters to extract from your program, the evaporation and the plant usage and everything, a lot of this country, I mean, not every field in Bighorn County has got a creek going through it or close enough to a river, but there's an awful lot of submoisture in this county.
Yeah.
How do you figure that into it?
That's
You
where
have- you have
these
to go down
things
and-
really pay for themselves. Because right now, well, Tyler didn't tell you, but that first, when he put that wheel line with the sunshine behind it, the first couple of pictures, that's my wheel line.
Oh.
And I got these things out in my field. Now, they're picking up moisture that I didn't apply. They're picking up dew and high humidity, you know, and that's what I tell people, these things are,
Typically, when we do those soil moisture sensors, we have them at different depths. It's, what is that for IWM? Is it at 12 inches and 24
Yeah,
inches?
typically for a 4-foot depth, we have it at 1 foot and 3 foot, or 30 inches.
Okay.
Yeah.
Or somewhere in that 3 foot.
And that also, that tells you a lot too. It can be a huge difference when it's 30 inches down versus the sensor that reads it at 12 inches. So that's also part of, with monitoring those moisture sensors too, and that'll also tell you when you need to irrigate.
but that's what you just talked about, is these things. And that's the good idea of finding out moisture that you're getting either from wicking up of a river flowing underneath it. You don't know why, but maybe it's always really moist at 4 feet. Why? Well, you're getting an influence from something. If you can see your shallow sensor, one no deeper than this, is building moisture, but you didn't apply it, then it's the dew. It's the humidity. Walk out in your grass, first part of June with no rain. Why are your feet wet in the morning? It's the dew. That plant is getting dew that's getting into the ground and getting into the moisture. Then you got the canopy of the crop, and it's a microenvironment in that canopy that your alfalfa soil, after days of not applying water, is still wet. Why is that? It's that microclimate.
Usually because you want to cut it for hay.
Yeah. But that's what these things can pick up. That's what, and I run these things on mine, and that's what I can see. And yeah, sometimes I'm falling into that crop stress, but I'm trying to get out of it as soon as I can too. But yeah, I'm seeing a lot of the dew and stuff picked up in alfalfa. Okay, irrigation timing and sets. So irrigation timing, we use the word frequency. Basically, should be, that's a nice gentle way in letting you be the decision maker. You should be applying water. Now, if I wanted to be a dictator, I'd say you will be applying water before crop stress happens. Field monitoring can be used to establish and when and how much to irrigate. So you can, one way we're using these things in irrigation on borders is if you see this thing read a number like 40 or 30 or 50, and you start to irrigate, irrigation water will wick up this too if it's under tension. So when this gauge goes back to 0, that is completely irrigated at that zone. So you can shut the water off if you're a deep one. You're deep one. So if you got 2 or 3 of these sensors, one's at, what'd you say, 12 inches, one's at 24 or something?
30 to 36.
Okay, 30. If your 24-inch one is reading something and your 30-inch one is reading something else, But the 24 will get to 0 before the 30 will. But when the 30 hits 0, shut your water off because you still got gravitational water moving down. So that's going to get to the lower roots. But that's a good way to figure your establishment of your frequency. I'm going to hit the wrong button. I'm looking for the pointer. Okay, so what I talked about was the management allowed deficiency, and that's what we see we can use in most crops in Montana: alfalfa, alfalfa, pasture, sugar beets, a few others. They all say about 50% or half of the water that's available is used up. But if you're growing beans, peas, that's more like you can only use like 30% of the water. Potatoes in the Manhattan area, it's 30%. Those potatoes don't want to go dry. And those growers don't want to let the potatoes grow dry. So that's when they need to re-irrigate. That's why you see so many acres of those potatoes under a pivot right now. They are not letting them go dry. Like Tyler said, if you can get a 1-inch rain shower every 2 to 3 days, isn't that perfect? Isn't life good? If you're a potato, you're going to say, yeah, that's pretty good, and that's where you want to be. So there's a formula that we can use to figure out flow rate, say. Or we can use it to figure out time of set or depth of water that we applied on a given acres. And it's a simple formula. It's Q times T equals D times A. It does not, now this depth is going to be your gross water. It's not what Evan talked about, efficiencies of systems. The efficiency is not thrown into this equation yet. Now, here's the example. If you can flow 1 cubic foot per second for 1 hour, that equals 1 inch over 1 acre. That's how easy that 1, 1, 1 equals 1, 1, 1. Okay, salinity and other issues now start to work against you with that water holding capacity. Like Evan said, the salts that you see in well water, that can cause accumulation in the root zone and therefore affect the plants and to extend the crop yields after. I mean, it is bad for crops, but is it bad for irrigating? We might think so in Montana, but I'll tell you, California, where you are growing, where those crops that you're buying today in Albertsons and those stores, those are all grown in the Coachella Valley of California, and they irrigate with salty water. How can they do that? Because they do what is called leaching. Well, I'm getting ahead of myself, but when we see salinity, this is what we're typical seeing. A crop that only wants to grow in a wet area that has salt to it. The Golden Triangle section of Montana, the Great Falls, Havre, Cut Bank area has a lot of saline seep issues because of the crops that are growing out there and the deep percolation of water. But a glass of water could be saline. You can't see the saline. And that was my point of putting these two together. You can't really see that. So when we see...
have that printout.
Yeah, okay, good. You got this printout. This is about a 4-page printout. This item is, when you figure out your EC level, and that's a water test that tells you that, okay? This tells you what kind of crops can handle what kind of salt level, and then what kind of yield loss they would see once you get above that level. Okay, so there's a good reason why in the Golden Triangle we see a lot of grain crops like barley. You know, they can take the salts, and salts are in the soil, and maybe salts are in the water. and it builds up. Beans are an indicator of a salt problem. You got anything over 1 EC, and that's the measurable unit of salinity, then your beans can go. And when they go at a 19 is a rapid reduction of yield. That's 19% of yield loss per anything over 1. So if you got 2, you're 1 above 1. So you got 19% yield loss with an EC of 2. 3, you've got 38% loss of a bean crop. So beans could definitely show you that. I think another one on your chart could be onions. Why don't we grow onions where we could grow onions? Because of the salt. Onions can't take much either. They're in that handout. They're not, I didn't get them on this chart. But this is a really handy chart for you to have. So now that you see that it's the salt tolerance of all these crops. If you want to put fruit trees in your yard, now you've got the fruit trees on this thing, and you can see the EC. So the whole point of this is get your water tested. Find out your level of EC in your water from your well that you're irrigating your crops with, or the canal water that you're irrigating your field with, and find out if you got limitations. Okay, but here's my question going back to, well, no, I'll just go through this thing. So if we have an EC of, well, let me go back here. Okay, EC of barley, and I showed that to you. It could take 8 millimoles per centimeter. It starts to decline with a slope of 5%. So it's 5% isn't much of a field loss. You don't know why you didn't get 100 bushel of barley, maybe you got 95. Well, that could have been the reason. Okay, corn has a tolerance of 1.7 with a slope of 12. So those are right out of that chart that I gave you. So if we're using irrigation water with 2, will you see a reduction in yield? That's what this is showing me. So if I'm looking at barley, will I see a reduction? Well, the way you figure a reduction is you take the EC of the water, subtract the EC tolerance of the crop, and multiply by the yield loss. Well, that whole thing gives me a negative number, so I would not see a reduction with that EC water on barley. But now, you get talked into putting corn into your rotation. Will you see an EC on that corn? So the same formula, you take the EC of the water, subtract the corn, multiply by the slope. So in corn, you would see roughly a 4% reduction in the corn. Yes?
You talk about taking water samples to get your EC value in your water.
Mm-hmm.
Well, in this country where we irrigate out of the rivers, how the heck do you keep up with that? That's
Well,
got to be a fluctuating number.
I would say, I saw a lot of people on the Powder River.
Yeah.
And, they would not want to irrigate after a big, high water level of the Powder. I don't know, I didn't quite get it, so I shouldn't even use it as an example. But you don't
I
take
understand
samples.
what you're saying about the Powder River, because the Powder River drainage goes
Yeah.
way up in Wyoming, and there's an awful lot of salt in that country. And it comes down, it'll go down in the water, and it'll get in the river after a lot of rain and stuff like that. I can see what you're saying with that.
I think ours are
Yeah.
pretty stable.
I'd say take a sample of the river probably at the time you need most of the water, so July. See what it's like in July. You don't have to take samples all the time, and you're only getting one sample. So you got a baseline condition, and that's what you could use in this whole thing. Because I think the water quality would be better after the snow melt and the rivers go up, and that's when you're growing things in May. And then about August, when it starts to get choice, I'll call it, that's probably more salinity in that, if there's any salinity in it. Yeah. So,
Probably
just,
it'd be smarter if you took 2 or 3 of them throughout the season. That
yeah,
would
I mean,
give
the
you
more
kind
you
of
take,
a
but this water
idea.
test is roughly about $100 a test, so you gotta throw that into the equation of the calculation and the economic side of it.
Sure.
So how do you use, how do you use that reduction in yield loss? Well, if you have historical values of 120 bushel on corn, you would see roughly 115 as your new condition with salinity. And I can tell you, if your soil isn't the same as the water, maybe your soil is 1, but in this case, we have water that's 2, your soil will become 2 and become 3 and become 4. If the longer you use and apply that water at a very efficient rate. And that's where you gotta break that cycle, basically. And that's the only economical means of salt control, is to ensure a net drawdown flow of the water through the crop root over time. That is known as leaching with irrigation water. That's what California does to provide you with lettuce in December. And that's applying more water than what your crop would need. So there's calculations, and they're big, they're cumbersome, they're doable. And Evan raised his hand if he would be glad to do those for any of you guys in this room.
Going for Randall.
So basically what you're saying is they wash the salinity out of the soil.
With salinity water. Yeah.
What about don't they try to change some of that with tiles and things of that nature, dry it out, or?
Yeah, in that valley, they drain all the fields.
Uh-huh.
And that's what keeps the soil at the water EC and not build up, because they can drain the water out.
Yeah.
And they send it into the Salton Sea, which is getting saltier and saltier and saltier in that south west part or southeast part of California. So, but there's ways of doing it. So there's a different formula. If you got a frequent irrigation, and that would include pivot or micro irrigation, or you have conventional flood wheel line, there's 2 different ways to get your leaching fraction. And then your leaching fraction is basically going to give you a % of water that you got to over apply. So in this example, and if you're really bored with your television program on a Wednesday night on your local channel, go through this 2 sheets again and follow the math, and you'll see that you got to add 29% more water to a crop. So your corn in your area of Montana would use 18 inches roughly of irrigation water or precipitation from rainfall. Well, you apply 29% more, you got to apply 25.5 inches to leach out that salt for that corn crop. And that is considered beneficial use of irrigation water, by the way. But now I want to go back to what I heard talked about wells decreasing, pivots decreasing the wells. I don't buy it in a lot of Montana, because this is the water you're drinking. If you think the recharge is the good water, I mean, you're dropping your well water, but your water quality is becoming bad. They don't want to see water quality getting back to the rivers, I'll say downstream of Billings, because you got, with the sugar beets, you got a heavy, heavy load of nitrogen for those sugar beets. That gets into the water. Well, you guys have moss issues. That's growing because there's excess nutrients getting into the rivers or the water. Now, if you have a application that's 85% efficient, so you got one of those efficient systems, you got to put 30 inches when you throw efficiency into the equation. So that's what all of that is showing you there. It's possible, it is possible to irrigate with salty water in salty soils. Okay, and if you would like to know the better way, well, I already said, contact Evan. But Evan, you can contact me. I'm not going to leave you hanging out here by
I
yourself.
appreciate that.
So, why do you need to know your soils? Well, throughout this presentation, you heard me talk about water holding capacity, salinity, frequency, crop rooting depth, and irrigation water management. And all of those are soil and crop based. Okay, so how many of you guys know the texture of the soil in your garden plot? Okay, that's good. How many of you can determine the percent rock by looking at the soil? And what is it 6 inches below the soil? And where is the gravel layer? And what is the level of salinity? Well, all of those are soils based. And do you recall the tools? If I said, what's this one called? Who said that? Perfect. What's this one called?
Potential.
A soil moisture sensor. This one? Yeah.
Whole bunch.
This one?
Floating.
Yep. So, all of those came up. All of those are on this table. And they're all good tools to use. These roughly cost $60 to $100, depending on the length. $35 for this. $220 for the meter to read them. 40, you said?
I think like 40 or
45 for that. I'd say well worth it. When you talk about, am I applying too much water or too little water? I gave one of the gentlemen that I work with a foot tensiometer to put in his garden spot. He gets billed from the city on the water use. He has soaker hose going through his garden spot. He put one of these out there, and his number didn't go off zero. He was so shocked of how much water he was applying. But he couldn't see that down a foot. When he shut his water off to his garden, watched that number climb, and would turn it back on when it hit 35 or 40, and go back to zero. He cut off 50% of his water bill. It was going to his garden, and he was over irrigating his garden. And that's what this thing told him. So this thing cost $70, but he saved that in 2 years. Now the whole idea is, these aren't put in the ground and leave in the ground. They're filled with water. You don't want them to freeze. Okay, so you got to remove them. They're sticking this high above the field. If you go and have this in a hay field, you just cut it off. And now it's no good. You can get the company to repair it, but that's not a freebie after that. So you got to watch your harvesting. These you pull out of the ground during harvest or freezing. These you leave in the ground during harvest, planting, whatever. They're in the ground. You just got to find the wires when you're done with them. Okay, I think that's it.
Thanks, Ray.